Welcome to another logic video with Kamran, your logic professor. So this problem comes at the request of a student in my Monday class. This should be from chapter 20 in our textbook, the Paul Herrick book. This is problem 20 from exercise 20.3, number 36. And this means that we'll have to use rules of replacement and rules of inference, but we won't need the conditional or indirect proof yet. This video kind of assumes that you know the rules, that you know all the rules, or at least you have the rule sheet in front of you, so you can look back. And as always, I recommend pausing the video before moving forward. Now, most of the videos I don't know the solution, or I haven't done the proof, and I try to figure it out in the video so you can see how I'm thinking, and I explain everything on the way. But this one I did figure it out earlier. Since the student was looking for a solution, I was working on it this afternoon before I had access to my video equipment. And now I'll try to explain everything. But just a little bit about how I went about doing this. I had a lot of false starts. I think it was not until my fourth or fifth attempt at this that I was on the right road. The first things I tried doing was to use implication on line 1. I was trying to get this to be a conjunction or split them apart in some way. So I was throwing negations onto the beginning of these, using implication to turn this into a disjunction, and just various things to try to get an equivalence. That didn't seem to go anywhere. Then I tried to use De Morgan's and other tools to get A or B or something like this so that I could use an A here in some way to either set up a modus tollens or a disjunctive syllogism. Then I realized that wasn't going to work. But then I realized something, and it has to do with the I in premise 3 and the conditional up here. So I'm going to try to say these things, and as usual, I think you should try to, pause the video right now. I'll give you hints, see if you can figure that out. So I'm saying it has something to do with the I right here. It's our starting point, and I'm going to try to plug it in here somewhere. So you notice this is a conditional. And if I can have the antecedent, if I can have if j, then I, then that would prove if I, then j. And if I had both of those, if I had if j, then I, and if I, then j, well, that would mean I could use equivalence and get if I, if and only j. I'm going to have to be better at my handwriting here. Okay. So this is what I recall. Premise 3, I know that I is true. I is definitely true from premise 3. In fact, I'm just going to write I from 3 simplification. Okay. Now, I know that I is true. And if I'm trying to set up this conditional, if j, then I, and if I is true, then recall from the conditional, it doesn't matter what j is. J could be true or j could be false. If you remember your truth table, or you remember how conditional operates, a conditional is only treated as false in the language of logic if the conditional is broken in some way. So the only way this could be false is if j was true and I was false. But in every other case, if j is false and I is false, if j is false and I is true, if they're both true, then the statement's always treated as true. And if the statement is true, that means the antecedent is true. And if the antecedent is true, then we can use modus ponens. So, if we know I is true, and the I is the consequent, then this statement will always be true regardless of j's truth value. So in other words, if we know I, we should be able to deduce if j, then I. The only question is, what rules would allow me to do that? There's got to be some set of rules that does that. So maybe this is a good time to pause it and see if you can figure it out. But let's move on. How would I take I and add j? Well, our rule of addition allows us to do something like this. I or not j. And we know that from just for and addition. All right, now we can use commutation to give us not j, therefore I. And that is 5 commutation. I think that's the biggest difficulty of this one. As we go through this, this should not be a not j. When we do implication, we lose that not. We have if j then I. Now we can use modus ponens, giving us if I then j. And that is from 1,6 modus ponens. 8, we can put these on the same line. I know my handwriting still is really bad on this. I think Friday I made 6 of these, and my handwriting was slowly getting better. But then I had a lot going on the weekend and fell out of practice already. So that's 6 and 7 conjunction. We have if j then I, and if I then j. As I'm talking about my handwriting, I just notice it gets worse and worse. So now we have those two conditionals. Using equivalence, we have j is equivalent to I. That's from 8 equivalence. All right. Now on 10. Notice premise 2. We have now affirmed the antecedent, so this is not A and not B. Placement of the parentheses is important here, so that's 9, that's not 9, that's, yeah, well, technically 2, 9 modus ponens. Now 11, we can use De Morgan, not A, or not B. That's 10 De Morgan. Then 12, we can use double negation. That's 11 DN for double negation. 13, we're going to go back to premise 3 and simplify the A. So that is 3 simplification. 14, we'll do double negation there on 13 DN. And then we can use disjunctive syllogism on 12 and 14 B. So that's 12, 14 DS. And then conjunction 13 and 15. And there you go. There's your conclusion. So I really do think the most difficult part was just seeing that first thing, that if you have the I and use addition, you get the implication. And once you have this, I mean, imagine if this was one of your starting premises, then it would have been a much easier problem. If you just had if j then I as your starting premise. But if you just have an I, you can get to if j then I. It's so counterintuitive. It's one of those strange features of logic that you learn it. You learn about addition, you're like, okay, I got it. You learn about implication, like, okay, I got it. But then it's like takes practice to see how to use these rules in different situations. Like you learn the strategy of the rules. And it just takes practice, 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 practice. All right. And I should say reflection, like thinking, oh, when was that series of rules? What patterns was that series of rules able to solve? And you'll start to learn them and be able to recognize when you do them. All right, well, that's it for this video. Thanks for watching. Hope it was helpful. And if there are other problems you want me to solve or go through, I'm happy to do it. Goodbye for now.